2012 Physics Senior External Exam, Paper 1, Part B, Short Response, Question 6. Respond to Question 6 on page 27 of your response book, which I have cut out and attached here below the question. The following data was collected during an experiment using springs. We have forces running from 0 to 40 newtons, and we have extensions running from 0 to 20 centimeters. Part A, draw a graph of force versus extension worth 3 marks. Part B, find the spring constant, which is the gradient of our force extension graph. And Part C, find the stored elastic potential energy in the spring when it has been stretched by 17 centimeters worth 1 mark. Looking at this with the graph paper, you can see that the important part to notice is the maximum force of 40 and the maximum extension of 20 centimeters. So when we draw our graph, we need to go from our minimum to our maximum. So we need to go from 0 to 40 on our vertical axis, which is our force axis. On our horizontal axis, we need to go from 0 to 20. So if I just move my page slightly and I adjust the camera to be looking at the graph, and I'll just zoom out a bit as well too. Let me just get this focused. There we go. We're on our graph paper now. Our vertical axis. The vertical axis needs to go up to 40. So on the axis here, 4, 8, 12, 16, 17, there's 18 squares on the way up. So going each 4 squares is 10, 10, 20, 30, 40. This is my force axis. So let me just capture that for you slightly. There we go. And I need to put the units, and I put the units in brackets. So I have a force here of 40 Newton starting at 0. Let me just adjust my camera again so I'm 0 here. Now on my horizontal axis, which is my x-axis, which is my extension, and I'm going to make the units here meters. Now in the table they're in centimeters. And so going across, we're talking about an extension of 0.05, 0.1, 0.15, 0.20. So there we have the points of our graph. X horizontal extension in meters. So this is the extension. So let's label that. And here, let's label this force. Okay, just adjust my camera for you slightly again. Now I can plot points. I can plot the point 40 Newton and 20 centimeters, which is 0.2 meters, which is this particular point here. 30 and 15 centimeters, which is this point here. 20 Newton and 10 centimeters, which is this point here. 10 Newton and 5 centimeters, which is this point here. So there we go. I've got myself a beautiful line. Now, as with all lines of best fit, you put your ruler on your points, and with a pencil, a sharp pencil, you rule through your line of best fit like so. So there is my force extension graph. Now, part A done. Let's do part B. Find the spring constant. Now we know that F is equal to K times X. So therefore we're after the K value. K is equal to F over X. Alright, so K being equal to F over X, that's the gradient. Because it goes through the origin, a rise of 40 is a run of 0.2. So a rise of 40 is a run of 0.2. So with my calculator, 40 divided by 0.2 equals, I get a spring constant there, K is equal to 200. And it's 200 Newton per meter. Now, part C. I'm now required here the elastic potential energy. The energy stored in the spring is given by a half kx squared. So we can go through now, we can do this calculation. A half multiplied by k, which is 200, multiplied by the extension squared. Now, the particular question, I'll slide the camera up. Here's the important bit of information when the string is stretched 17 centimeters. So this is 0.17 squared. So if I grab my calculator back, I've got my 200 in there from previous. I divided by 2 and I multiply it by 0.17. I multiply it by 0.17 and I get an answer of 2.89. 2.89, and that answer will be in Joule.